In section 4, part 1, we're going to take a look at trigonometric ratios and trigonometry. So we're going to start off with what is trigonometry. And trigonometry is the measuring of angles and sides of triangles. We're going to specifically look at right triangles to start with, but trigonometry can be applied to any triangle. And then next we want to talk about how is trigonometry associated with similar triangles. So remember, similar triangles, we could prove them similar by two corresponding angles being congruent, all three sides being corresponding sides being proportional, and then two corresponding sides being proportional and their included angle being congruent. So what we can do in trigonometry is we can use trigonometric ratios to show that two triangles have proportional sides. So let's take a look at a right triangle with sides A, B, and C. Okay. First, we want to talk about the hypotenuse. And as you recall from the Pythagorean theorem, the hypotenuse is the longest side, and it is across from the 90-degree angle. So in our triangle, side AB is the hypotenuse. We also have what's called the opposite side and the adjacent side. Now the opposite side and adjacent side are based on which angle you're looking at in the triangle. So let's start with angle B. Its opposite side would be the side across from the acute angle. So in our case, the opposite side would be side AC. It is opposite of angle B. Okay. We then have the adjacent side. And the adjacent side is the side next to an acute angle. So in our picture, side BC would be our adjacent side of angle B. Now, if we look at a different angle, we have different opposite and adjacent sides. So if we were to look at angle A, it has a different opposite and adjacent side because the opposite side to angle A would be BC. It is opposite of angle A. And then the adjacent side to angle A would be AC. So the opposite and adjacent sides are not like the hypotenuse where it's always a specific side. It's dependent on which angle you're looking at in your right triangle. That leads us into the ratios of the sides. They're called the trigonometric ratios, and there are three that we're going to talk about: sine, cosine, and tangent. So when you're looking at a right triangle, we talk about that acute angle we're looking at as theta. That's what this Greek letter represents, theta. It's the angle we are looking at. So we label the opposite, adjacent, and hypotenuse of our triangle based on that angle theta. And sine of theta, the ratio, is always the opposite side over the hypotenuse. The cosine of theta is always the adjacent side over the hypotenuse, and then the tangent of theta is always the opposite side over the adjacent side. And we can use something called SOHCAHTOA to help us remember these. They're abbreviations for those ratios. So sine is the opposite over the hypotenuse. Ca, which is cosine, is the adjacent over the hypotenuse. And then TOA, which is tangent, is the opposite over the adjacent. So SOHCAHTOA helps us remember the ratios for sine, cosine, and tangent. We're now going to use our trig ratios to solve, we're going to now use the trig ratios in some right triangles. So we want to find the trig ratios for angle x in our triangle. So here's angle x. So we start with sine. So sine is abbreviated SIN, and then we put our angle x equals our opposite side. Let's go ahead and label our three sides. Our opposite side, 32, over our hypotenuse, 40. Now 32 over 40 is not the simplified fraction for our ratio, and you always want to simplify it. When we simplify 32 over 40, we get 4/5. Okay. Next, we want to do cosine of x, which is abbreviated COS. It is the adjacent side, 24, over the hypotenuse, 40. And again, 24 over 40 can simplify, and it becomes 3/5. And lastly, tangent of x, which is abbreviated TAN, equals the opposite side, 32, over the adjacent side, 24, and then 32 over 24 can simplify, and it becomes 4/3. So we have written the three trig ratios for our angle x. We're going to do the same thing in our next triangle, find the trig ratios for angle x. So we find angle x. We're going to then label our three sides, opposite, adjacent, and hypotenuse. Always start with sine. So sine of x equals the opposite side, 30, over the hypotenuse, 50, and 30 over 50 simplifies to 3/5. Cosine of x equals the adjacent side, 40, over the hypotenuse, 50, which simplifies to 4/5. And lastly, tangent of x, which is the opposite side, 30, over the adjacent side, 40, which simplifies to 3/4. So as long as you can identify the opposite, adjacent, and hypotenuse side for whatever angle you're looking at in a triangle, just becomes knowing which trig ratio is which ratio. We can also find trig ratios with a calculator. So what we can do is we can evaluate a trig ratio using a calculator. If the side lengths are unknown. And one of the important things you want to do is make sure your calculator is in degree mode. And they should be, but just in case, if you want to check, just ask me. I'll tell you how to put your calculator in degree mode. So we're going to find the following trig ratios with a calculator and explain what that means. So I want to know what the sine of 33 degrees is. So when I type, there is a sine button on the calculator, SIN, so you hit the button, then you type in 33, then you hit enter, and it's going to give you a decimal, and we're going to round 4 decimal places, and we're going to get sine of 33 equals 0.5446. Now, what does this mean? Well, if remember, sine is the ratio of the opposite side and the hypotenuse. So this tells us that the ratio of the opposite side and the hypotenuse of a right triangle with a 33-degree angle is 0.5446. So I don't need to know what the opposite side and the hypotenuse are. I just know that when I divide those two numbers, I'm going to get 0.5446. And this is specifically for a 33-degree angle. And of course, we are talking about right triangles as well. Next, we're going to look at cosine of 88 degrees, which is cosine is also a button on your calculator. So when we find cosine of 88, we get 0.0349. So it's going to be a very similar statement about what this means, except cosine is the ratio of the adjacent side and the hypotenuse. So the ratio of the adjacent side and hypotenuse of a right triangle with an 88-degree angle is 0.0349. Lastly, we're going to take a look at tangent of 10 degrees. So there is also a tangent button on the calculator, and when you evaluate tangent of 10 degrees, you get 0.1763. So again, it's going to be a very similar statement to the previous two, except tangent is the ratio of the opposite side and the adjacent side. So the ratio of the opposite side and the adjacent side of a right triangle with a 10-degree angle is 0.1763. And the reason we're talking about how to use a calculator to evaluate a trig ratio is that we can use this to find missing sides of right triangles. So we've typically talked about how to use the Pythagorean theorem to find the missing side of a right triangle. But what if you're not given two of the three sides? You're only given one of them, but you're given an angle measure inside. And that's where the trig ratios are going to come into play. So we want to find the missing side x in our right triangle, given we have a 21-degree angle and one of our sides is 22. So we have to figure out what side the x side and the 22 side are in relation to our 21-degree angle. Well, the 22 is the easier side. It's the opposite our 90-degree angle, which means it is the hypotenuse. X is opposite the 21-degree angle. So it's important that if you don't have SOHCAHTOA written at the top of your paper, you do that now so you can, if you're struggling to remember the ratios. So we want to know which one uses the opposite side and the hypotenuse, and that's going to be sine. So we know sine of 21, since that's the angle we're given, equals the opposite side x over our hypotenuse 22. We now want to solve for x. Technically, we can put sine of 21 over 1. We now have a proportion, and the way we solve a proportion is cross multiply. So we get x equals 22 times the sine of 21. And all you have to do is type this in a calculator, and we end up with x equals 7.88. And it's always a good idea to round at least 2 decimal places in this case. That way you get a more accurate answer. So in our second example, we have our 72-degree angle, a side of length 6, and our side x. So the side with length 6 is adjacent to our 72-degree angle, and x is our hypotenuse. So looking back at SOHCAHTOA, the one that uses the adjacent side and the hypotenuse is cosine. So we have cosine of 72 degrees equals the adjacent side 6 over the hypotenuse x. Put cosine of 72 over 1 so we can cross multiply. We get x times the cosine of 72 equals 6. In order to get x by itself, we have to divide both sides by the cosine of 72. So we get x equals, and we type 6 divided by the cosine of 72 in a calculator, and we get that x equals 19.42. Last example, we have a right triangle with a 24-degree angle, our missing side x, and a side of 12. So the side of x is the opposite side to our 24-degree angle, and the side of length 12 is the adjacent side. So the trig ratio that uses opposite and adjacent is tangent. So we have tangent of 24 equals our opposite side x and our adjacent side 12. Put tangent of 24 over 1. We cross multiply. We get x equals 12 times the tangent of 24. Using a calculator to evaluate, we end up with x equals 5.34. So as you're working on the assignment, let me know if you have any questions about our trig ratios, how to set them up, how to solve for missing sides.